everyone, Justin here again. I am so happy to see you. I hope you enjoyed your unit on trigonometry. You've learned so much about right triangles, similar triangles, and you've even gotten pretty handy with a graphing calculator. But most importantly, you now know everything you need to know to help me figure out how tall my parents' tree is. In this video, we'll revisit the scenario from the beginning of the unit to determine the height of my parents' tree. Then we'll discuss how you can prepare for your unit assessment. It's been a while since the beginning of this unit, so let me give you a little refresher. My parents have this tree in their yard that they want to cut down to make room for a pool. But they need to know how tall this tree is because their town has environmental protection laws in place. They cannot cut down any tree that's taller than 20 feet. I went outside their house and did as much measuring as I could. I know that when I stand 10 feet away from the tree, that I make a right angle with the top of the tree. I also know that the angle from my eye line to the top of the tree is 50 degrees. Hey, wait a second. This diagram is starting to look awfully familiar. This 50-degree angle, that's the angle of elevation from my head to the top of the tree. If I want to find the height of the tree, I can just make that a variable, like x. From where I am, the height of the tree is the opposite side of the triangle, and my distance away from the tree is the adjacent side of the triangle. That means I'll be using tangent here. The tangent of 50 degrees is x over 10. Now all I have to do is multiply both sides by 10, and then I can enter this expression into my calculator, where I can see that the height of the tree is 11.9 feet. Wait a minute. 11.9 feet? That doesn't really make any sense. Like, I've seen this tree. I'm 6 feet tall, and this tree is definitely taller than two of me. Hold on, let me take a look at this again. Oh, I see. Look at this triangle. The bottom of this triangle is level with my head, not the ground. Okay, so the distance from my head to the top of the tree is 11.9 feet. Let's just add in another 6 feet of height to account for my height. And now I can see that the total height of the tree is approximately 17.9 feet. And 17.9 is less than 20 feet, meaning my parents can cut this tree down and put in a pool. I cannot wait for all the pool parties we're going to be having next year. But before I get too ahead of myself, let's talk a little bit about your upcoming unit assessment. Now that you've just about wrapped up your trigonometry unit, it is once again time to show what you know with an end of unit assessment. As always, you're going to want to start by working through the preparation materials in your notes template PDF. Then, make sure you have a graphing calculator handy before you start the assessment itself. Plus, I've got some handy tips for you to keep in mind so that you can make sure that you're doing your best. First, look closely to see if you should be using trig or inverse trig when you're solving. Remember, we use trig to solve for side ratios and inverse trig to solve for angle measures. Second, be on the lookout for those sneaky special right triangles. You should always hand calculate trig values for 30, 45, and 60 degree angles to make sure your answers are as exact as possible. Lastly, make sure you don't round any numbers until the very end of your calculations. This will help you avoid rounding errors in your final answers. If you keep these tips in mind, then all of your answers will be like the triangles we've been working through in this unit. Right. I cracked myself up. Anyway, I gotta go do some pool floaty shopping. Good luck on your assessment, and I will see you next time.